Center of mass. All the problems we've solved so far have assumed that we're dealing with point particles, even when they involve sleds, cars, and buckets. The problem solutions work due to the concept of center of mass. The center of mass of an object behaves as if all the mass of the object is concentrated at that point. So solving for the center of mass solves for the motion of the object. The calculation of the center of mass of an object is beyond the scope of this course, but there is a way to find it experimentally. Start with a plane lamina, and that just means a flat surface, in the shape of a circle. The lamina can be replaced with a point particle at its center with the same mass as the lamina. The point is located at the average of the distances from every location on the circle to the center of mass point. But what about an irregular shaped lamina as shown here? Well, here's our process. Attach the lamina to a horizontal bar with a string. Then attach a plumb bob, a weight, to the bottom of the string. The lamina will balance such that its center of mass in the vertical direction is along the string, so the moments of force will balance. So somewhere along this line will be the center of mass. So draw a line on the lamina that matches the plumb line. And here's our point of attachment up here. Next, attach the lamina to the horizontal bar at a second point of attachment and drop a plumb line from that point. The center of mass is at the intersection of the two plumb lines, right over here. The center of mass plays an important role in finding the stability of objects. When the location of the center of mass is low within an object, then it is stable. The higher the center of mass gets, the less stable the object. Race cars need to be stable as they have high speeds when they drive around curves. Engineers design the race cars to have a low center of mass so they don't tip over when they are in the curves. Trucks have higher centers of mass than race cars as they have to carry a lot of materials. They have to be very careful that they do not tip over when they make sharp turns. Trucks need to slow down when they make turns to be safe. As long as the center of mass is within the base of an object, it is stable. If the center of mass is outside this space, the moment of force exerted by gravity will twist it and topple it over. The shapes represent a truck making a turn. The first two pictures show the force of gravity acting on the center of mass within the base of the truck. So here's the center of mass. The gravitational force is the arrow. And in both cases, that is within the base. Okay, so the force is down. Your base is like this, so it's still within that base. The truck will not move in the first picture. The second picture shows the truck starting to move, starting to tip over, but it will move back without toppling over. The truck in the third picture, right over here, will not return to its original stable position. Stable means it's not going to top over. Unstable means it will topple over. The truck is tilted enough so that its center of mass is outside the base of the truck. So it will continue twisting due to the gravitational force until it topples over.